am a research scientist on the Sevilleta Long-Term Ecological Research Field Crew.
We're doing a long-term monitoring bee project, which consists of trapping bees in a few different traps. There's some out there. Altogether, there's 10 out here, and there's 20 more in 2 different sites. And that has been going on for about 20 years now. Since it started in 2002 by Karen Wright. And so it's been happening every year since. We collect the bees every month, starting from March all the way to October.
We are using this data to address the question, how do climate-driven changes in resource landscapes affect bee dynamics? The southwestern US is a global hotspot of bee biodiversity, and the SEV LTER supports what is to our knowledge the world's longest continuous bee monitoring study. For this research, we collect bees in simple funnel traps. This lets us examine changes in bee abundance and diversity from month to month and year to year. We've documented more than 325 bee species at the SEV sites. Our data identify changes in bee population and community dynamics and health over time in the context of climate change. For this work, a typical fieldwork day involves catching bees in a net directly from the flowers that they're visiting. We place the bees in vials and keep them in a cooler at a comfortable temperature. We then weigh the bees and place each one in an individual well in an environmental chamber. This chamber has a heating element and a fan that are used to control its temperature. We steadily raise the temperature in the chamber and observe how the bees respond. We use similar methods to measure the desiccation tolerance of bees, or how well they cope with dry conditions. So far, we found that about 1/3 of bee species are declining in abundance, 1/3 are increasing in abundance, and 1/3 have remained stable over time. These patterns are strongly related to drought conditions. The bees that are doing the best under climate change are the ones with high heat and desiccation tolerances in our experiments. This work is important because bees are critical pollinators of many of the world's flowering plants, and there is a global concern about recently documented bee abundance declines. Our work highlights that conserving bees and their pollination services requires studying how climate change is directly affecting bee fitness and population persistence.